In this section 4.3, we study encapsulation. It is very important concept. Let's think about encapsulation. At first, we need to know about the two views of an object. There are two views of an object. One is internal view and the other is external view. Internal view is the details of the variables and the methods of the class that defines it. External view is the services that an object provides and how the object interacts with the rest of the system. From the external view, an object is an encapsulated entity, providing a set of specific services. These services define the interface to the object. I will explain this in the next page. Let me explain internal view and external view. These two are student objects, and this is a professor object. The student objects are created by a student class, and professor object is created by professor class. Each student has its own attributes. That is name, address, major, GPA. Name, address, major, GPA. The professor has also its own attribute. That is name, address, major, and position. Each object, whether it is a student or a professor, must protect its own data. In other words, it is necessary to prevent unauthorized modification of attributes from outside the object. To do this, declare these attributes as private. Declare private and declare private. This is an internal view. Sometimes it is required for the professor and student object interact with each other. So sometimes they need some interaction. For example, if a student takes a professor's class, the two objects are related. And sometimes the student objects can interact with each other like this. You have to put this relationship into your coding. This is an internal view, external view. This is an external view. One object called the client may use another object for the services it provides. The client of an object may request its services, call its methods, but it should not have to be aware of how those services are accomplished. This is a black box concept. Any changes to the object state, that is its variables, should be made by that object's method. This means that we should make variable private and methods public so we can access variables through the methods. We should make it difficult, if not impossible, for a client to access an object's variables directly. That is, an object should be self-governing. An encapsulated object can be thought of as a black box. Its inner workings are hidden from the client. The client invokes the interface methods and they manage the instance data. If you understand this picture, I think you can understand the encapsulation. Think about this is a class. And here is the private data. And here is public method. And client wants to do something with this data. But since this data is private, client cannot directly access this data. To access this data, the client should use method. So this is the interface. So this means that data is private, encapsulated with public methods. So client can contact with methods to manipulate this one. And at this time, client doesn't have to know how these methods are implemented. This is the encapsulation. This example does not show any encapsulation. Here, attributes are declared as public. Public string name and public int age. And the constructor is also public, and void print method is also public. Until now, we declared attributes as private. However, here we declared as public. When declared as public like this, name and age can be accessed from outside this class. For example, here, this is outside of this class, outside of this person class. We create person object called PS. And PS has attributes value as Steve and 25. And when we print out this, then Steve and 25 will be printed out. And then this part, PS.name is Tom. This means that Tom should be stored in PS.name and 30 should be stored in PS.age. Name and age are attributes of the person. Since it is declared as public, we can use name and age directly outside this class. This is okay because name and age are public, so there is no encapsulation in this example. Now the access modifier of the age is changed from public to private. Then a compile error will occur here. The error message is this: the field person.age is not visible. Private member cannot be accessed from outside. That is, private members can be accessed inside only within this class. So we use age here and we use age here. This is okay. But outside this class, age cannot be used. So the compile error occurs here. We also change the name as private to private. Then you will get an error on both of these lines. And the error message is like this: name and age is not visible. This is an encapsulation. It is strongly recommended that attributes are declared private so that they cannot be accessed from the outside. That is, by declaring private like this, we can protect objects from unauthorized modification from outside the world. I will talk about visibility modifiers. In Java, we accomplish encapsulation through the appropriate use of visibility modifiers. A modifier is a Java reserved word that specifies particular characteristics of a method or data. We have used final modifier to define constants. I think you remember this one. Java has 3 visibility modifiers: public, protected, and private. The protected modifier involves inheritance, which we will discuss later. So now I hope you understand public and private. I'll explain more. Members of a class that are declared with public visibility can be referenced anywhere. Members of a class that are declared with private visibility can be referenced only within that class. Members declared without a visibility modifier have default visibility and can be referenced by any class in the same package. So there are 4 visibility in Java: private, protected, public, and if there is nothing specified here, then it is the default visibility. So private is, as you know, private visibility is the most strong visibility because it cannot be accessed outside the class. So this is the strong visibility. So I'll talk about this more. There are 2 classes here, student and student test. These 2 classes are in the same package. And here, the name and the score, these two attributes, are default access because there are nothing here. So this is not private and this is not public. So we call this default access visibility. So this data can be accessed by other class in the same package. This means that name and score can be accessed in student test class because student and student test class are in the same package. So this is okay. I'll say one more time. Public members can be referenced anywhere. Default members can be referenced by any class in the same package. Private members can be referenced only within that class. I will say something more about default visibility. There are two packages here, and each package has two classes. In account.java, in account class, there is an attribute account name. It is a default visibility because there is nothing here, not private or nor public. So account name is default. So since this is default access, account name can be accessed by VIP because these are in the same package. However, account name cannot be accessed by branch or main office class. This is because these two classes are in the different package from account class. Public variables violate encapsulation because they allow the client to modify the values directly. I think you understand this one. Therefore, instance variables should not be declared with public visibility. It is acceptable to give a constant public visibility, which allows it to be used outside of the class. Public constants do not violate encapsulation because although the client can access it, its value cannot be changed. Can you understand this one? Constant cannot be changed, so it is okay to be declared as public. It means like that. Methods that provide the object services are declared with public visibility so that they can be invoked by clients. Public methods are also called service methods. A method created simply to assist a service method is called support method. Since a support method is not intended to be called by a client, it should not be declared with public visibility. So there are two kinds of methods. One is service method and the other is support method. So service method should be declared public to service to the outside world. And support method can be declared as private because support method only used by the service methods inside the class. I'll talk about service method and support method. Not only attributes, but also methods can be declared as private. Members declared as private can only be used within that class. So, methods declared as private cannot be accessed from outside the class. Methods declared as private are used to support other methods in the same class. These methods are called support method. So in this example, show method declared as private and check method is declared as public. So check method can be accessed from the outside this class, but show method cannot be accessed from outside. So the purpose of this show method is to support other methods in the same class. In this case, we call this kind of method as support method, and the public method is called a service method. When you design a class, please keep this in mind. If variables are declared public, it violates encapsulation. It is strongly recommended that variables be declared as private to enforce encapsulation. The method for providing services to clients is declared public. And methods, if a method is intended to support another method in the same class, then declare it as private. So please keep this in mind when you design a class. I will explain accessors and mutators. Because instance data is private, a class usually provides services to access and modify data values. An accessor method returns the current value of a variable to get the value. A mutator method changes the value of a variable, so set the value. The names of accessor and mutator methods take the form getX and setX, where X is the name of the value. So here, X should be replaced with the variable name. They are sometimes called getters and setters. I will explain this using examples. Here is a rectangle class. There are two attributes, length and width. Both are declared as private. So we can think that they are inside this object privately. And to access or modify these two values, we need a public method to do that. Here, send method are for setting values to attributes, and get method are for getting values of attributes. We say that send methods are mutators because it is change of value, and it is recommended that to make the name like this, set and variable name, so set length and set width. Likewise, it is recommended to make a name for accessors, getters, as get and a variable name, like get length and get width. So usually in the class, there are private attributes and setters and getters for these attributes. You can use accessor like this. At first make two rectangle objects, and then if we want compute the area of these rectangles, we need to get length and width of each rectangle. So in that case, since length and width are in private member, we cannot access directly. So we use getters, accessors like this. So r1.getLength will have this value. This value 2 will be returned here, and then r1.getWidth will have this 7. So 7 will be returned here. Likewise, r2.getLength will get the value of length of r2, so 3 will be returned here, and then r2getWidth will have 6 returned here. So like this, if we want to access private member, then we have like this kind of accessors, getters, as public method. This is an example of setters, mutators. At first make two objects, then object will be created like this, and length and width are private members, so we cannot access directly. If we want to change the value of the private member, we use send method, mutators, like this. So if we write a set with 10, this means that the width of R1 will be changed to 10. So the 7 will be changed to 10. And R2.setLength 5 means that change the length of R2 will be changed to 5. So 3 will be changed to 5, like this. Sometimes there are some mutator restrictions. The use of mutators gives the class designer the ability to restrict a client's options to modify an object's state. A mutator is often designed so that the value of variables can be set only within particular limits. We will see in Chapter 5 how restrictions can be implemented. A quick check, and this is the code from the textbook. Think about the answers from this code. The first one, why was the face value variable declared as private in the die class? In the die class, face value is private. Why is that? It's because by making it private, each die object controls its own data and allows it to be modified only by the well-defined operations it provides. This means that the face value is private because we should protect this data. And to access this data, we can use setter, mutator, or getter, accessor, like this. And why is it okay to declare max as public in the die class? In the die class, max is declared as public. Usually, we declare as public for the attribute, but this time max is declared as public. It is because max is a constant. Its value cannot be changed. Therefore, there is no violation of encapsulation.